Hi everyone. Hopefully you had a great day today. And I'm just going to show you how to do some double and triple bonds. So we're going to start with double bonds. And what I would do on this one is just watch how I bond oxygen gas, which is O2. And then once I'm done that one, you can pause the video if you want and then try carbon dioxide. If you still don't quite get it, then just watch the video on these two. And then you can do the same on the other 2 pages that I'm going to be showing you as well. Okay? All right. So the first thing, like always, is we are doing the game plans, right? So O2 has 2 oxygens. So we're going to have an oxygen here. And even though it's the same atom, I'll just do a different color. Okay. So what I was talking about in the video is sometimes you're going to bond single electrons. So let's just say this one and this one hook up. Now, if I just stop there, I know it's not bonded correctly because I have a single electron there and I have a single electron there. Now, the other thing you have to remember is atoms don't like getting a third atom involved if you had an opportunity. Now, there's no chance of this in this one, but maybe in CO2 I'll show you. So you have no other choice, but this one and this one have to hook up together, okay? Now again, most grade 11 students have no problem putting that together. What they have a problem with is how the heck do you actually draw that? And what you have to remember, and what I start with on this scenario, is you have to remember that a double bond is going to look like this. Okay, so this is a shared pair of electrons here, the X and the dot, and then this X and this dot is another shared pair of electrons. So this is the oxygen that I had green. So then these 2 pair of electrons I'm just going to put up there, and these 2 electrons I'm just going to put right there. Where you put them around the oxygen really doesn't matter until you get to university. Then your professor may care where you put them. Now the same thing happens with this, right? This is from the blue oxygen that I had. So there's my oxygen. Again, those 2 right here are not paired anywhere. So I'm just going to put them there. And then these 2 aren't anywhere else, so I'll put them there. So that's what it would look like. Okay? Now, technically, they would try and arrange themselves so they're equally spaced apart. But again, you don't really have to worry about that. Now we got to do electronegativities. So electronegativities, oxygen is 3.5. The other oxygen is going to be exactly the same. When we subtract them, we get 0, which is a non-polar covalent bond. So we don't have slightly positive or slightly negative signs there. And then if I want to draw the structural diagram, I have an oxygen, double bond, 2 lines. Each line represents a shared pair of electrons. And then my other oxygen. And then I don't worry about showing any of the valence electrons. Okay? So there's that one. And now I'll show you carbon dioxide. So in carbon dioxide, we need carbon. And we need 2 oxygens. There's 1. And there's the second one. Now, how do we hook these up? Well, if you hooked up the oxygen, I'm not going to do it here because I don't want to mess up, but if you hook the oxygen up, right, imagine that hooked up, this one hooked up, and this one hooked up, what you're doing is you're creating, there's just really no chance to have enough electrons around carbon if you do it that way. So this is one of the annoying things about bonding because you'll think you have it right, and then when you show me, I'm just going to be like, no, it doesn't work like that. And sometimes everything may seem paired up and you're like, everything worked out. And then I'm just like, yeah, but it doesn't go together like that. Okay? Another helpful hint is the first element in the compound is usually the central atom and everything else tries to bond around it. It's not always the case, but most of the time that's the case. So what's going to happen here is I'm going to hook this one up here. And I'm going to hook this one up there. Okay, that's forming a double bond. And then this one would hook up there. And this one would hook up there. So I'm going to have 2 double bonds forming around both sides of the carbon. So again, what I'm going to do, carbon is in the middle, and a double bond is going to look like this. Always they look like this. Okay? And on the other side, a double bond is going to look like this. Now, when you're really good, you're just going to kind of put it together without doing this. But at first, and until you get really good at this, I would be putting it together exactly like I am. Okay? This oxygen is going to be, let's say, this one. So I'm going to put it there. And then I go back and I'm looking what other electrons do I have to place. It's very common at first is people forget to put these electrons in there. They do this basically. All right, and that's wrong because you need the other electrons. So again, these ones got to be placed. And again, you could put them right up there, and then those two you could put right there, and I would not mark them incorrect like that at all. Okay? Now, when you're looking at the electronegativity difference, the only bond that you're worried about here is the carbon-oxygen bond. Oxygen doesn't bond with oxygen, so we're not going to subtract those two. So oxygen, if I get that to work, is 3.5. Carbon has an electronegativity of 2.5. When I subtract them, I get 1. Now that's going to be a polar covalent bond. Now remember, with a polar covalent bond, the bigger number, the more electronegative atom becomes slightly negative, and the smaller number becomes slightly positive. So when I do the structural diagram for this, carbon, double bond, oxygen, double bond, oxygen, I have to put oxygen is slightly negative. This oxygen will also be slightly negative because it's the exact same bond in both directions. And then carbon is going to be slightly positive, and really you just have to draw one of them, and that's it. Okay? So that's how you do double bonds. Show you how to do triple bonds. And so here are two examples here. So the first example is pretty basic. So if we look, we need 2 nitrogens, right? So we got nitrogen, and we have another nitrogen. Now, how do we hook these guys up? Well, start, those two hook up. That's not going to be good enough, right? So let's hook those up. Still not good enough because I have a single electron there and a single electron there, so I have no choice, but I have to pair those guys up. So I'm going to get that. Now, what the heck is this going to look like? Well, a triple bond is going to look like this. 1, 2, 3. Those two are paired up. The middle ones are paired up. And the final ones are paired up. So a triple bond will always look like that. Now, sometimes you could draw them, like this if you wanted to. Okay, but all triple bonds are going to look like that. So the orange is nitrogen. And then again, remember these 2 electrons that were just sitting out doing nothing. I got to still draw them. You could put them anywhere, but technically, again, remember, if you're taking chemistry in university, you might as well start training yourself. They would try and arrange themselves to minimize repulsion, and they would end up being 180 degrees apart. So the green is another nitrogen. And again, those 2 electrons have to be placed somewhere. So I'm going to place them there. Okay? If I look at the electronegativity difference, nitrogen is 3.0. The other nitrogen is going to be exactly the same. So it's 0. And that's a non-polar covalent bond. So there's no slightly positive, slightly negative signs. And when I draw this, nitrogen, triple bond, another nitrogen. And that's what it would look like. I don't worry about those electrons or these ones here because they're not involved in bonds, and in a structural diagram, you don't show those. Okay? All right, C2H2. This is a tricky one. So I need 2 carbons. Put another carbon right there. And I need 2 hydrogens. So there's a hydrogen there, and there's a hydrogen there. Okay, now, I'm not going to show you kind of all the wrong ways to do this, but if you want, you can pause the video now and just tinker with it and see if you can get all of the electrons to be paired up. Okay? I'm not going to actually draw it, but if you hook this one up here, here, and here, these two end up being single still. That's just one of the ones that you can see that it wouldn't work. Okay? So, for this to work, if I hook this one up here, come on, change colors. And let's say I hook this one up here. Okay? 3 single electrons, so I know I'm on the right path. Hook those ones up, hook these ones up, hook those ones up. Every electron will be paired up, no single electrons left over, so we basically hit the jackpot. So again, in drawing this, I'm going to start with the triple bond. So all triple bonds appear like that. So the dotted ones was a carbon here, right? And I had a single electron still. And that would form, I'll change colors here, with the hydrogen. The X's are from a carbon. And don't forget I have this X left. Now you can draw it down there if you want, but again, remember that they're going to try and minimize repulsion. And that's going to hook up with that hydrogen. Now, when you do electronegativities, remember you're only subtracting 2 numbers at a time, and there are 2 different types of bonds here. There are 2 carbon-hydrogen bonds. There's one there, and there's one there. So we just have to do that math once. But there's a carbon-carbon triple bond. We have to take care of that as well. So carbon is, why aren't these working? There you go, 2.5. Hydrogen's electronegativity is 2.1. When we subtract it, we get 0.4, which is a non-polar covalent bond. No slightly positive, slightly negatives. Carbon, 2.5. The other carbon is 2.5. When I subtract those, I get 0, which again is a non-polar covalent bond. So I'm not going to have any slightly positive, slightly negatives on this. So my structural diagram, triple bond is 3 lines, carbon, and another hydrogen. And that's how we do that one. Okay? All right. Coordinate covalent bonds. These ones are nasty. So like I said in the note, these are last resort ones. I really wouldn't stress about these. Most grade 11s don't feel comfortable doing these, but honestly, you're going to see them on the bonding assignment, and if you pay attention to what I'm about to say, I think both of these are on the bonding assignment, so just look in your notes. But, man, I can't remember the last time I asked a coordinate covalent bonding one on the test or on the exam. They are very rare, okay? I'll kind of show you how you recognize them. So I know in your notes, N2O is done first, but I'm going to show you carbon monoxide first, okay? So carbon monoxide, we need a carbon. Oh my goodness, there we go. And we need an oxygen. Okay, so the obvious thing to do here is hook up here and hook up there. So if I just stop there, look what I've got. I've got a double bond, right? So the way we've done double bonds, we show them like that, and the oxygen's there. Now I'm not going to do anything else yet. If I do that, paired, that's good. And we don't like doing this often, but what you can do is you can make kind of like a Tennessee couple. Hopefully none of you guys are from Tennessee. I'm only joking, but we'll have a Tennessee couple and they're going to hook up, cousins. Okay? So if you do that, okay, great. It seems like everything would be paired up, right? Paired, they're now a pair. I got a pair there, everything's paired up. However, carbon 99.9% of the time needs 8 electrons around it. And this is not one of those 0.1% exceptions. So something has to happen. So what happens here is oxygen is going to be incredibly nice and say, you know what? See this pair of electrons here? I'm just going to let you share them with me. So what happens is those pair of electrons go there, form there. So carbon thinks this X is its own electron. Okay, so this is actually a triple bond. It has the strength of a triple bond. It's technically a double covalent bond and a single coordinate covalent bond. But once it forms, it's the equivalent of a triple bond. And then these two X's, these two electrons, we're sitting out doing nothing, and I'm going to put them there. You still have to do electronegativity differences. So oxygen, 3.5. Carbon is 2.5. When we subtract them, we get 1, which is a polar covalent bond. So remember, this is going to be slightly, if I can get it to work, negative. This is going to be slightly positive, okay? My structural diagram, carbon, remember I told you it was going to be like a triple bond. That's actually how you would draw that. Now a chemist that knows what they're doing would know it's not technically a triple bond in the sense that you wouldn't bond it like what I showed you on the last page. And then this is slightly positive, and then this is slightly negative on that side. Okay? The last one, N2O, so nitrogen. Need another nitrogen. And I need an oxygen. Now, if you want, you can pause the video and fiddle with this one. This is basically how this works. Now, this is rare. It doesn't normally happen like this, okay? Hook up, and hook up. So that's exactly how I showed you nitrogen forms, right? So we know that this would actually look like a nitrogen. 1, 2, 3 for a triple bond. Triple bond looks like that. And normally that'd be it. So you'd have an N2 molecule, but the problem is you have this oxygen sitting out by itself. And oxygen doesn't like sitting by itself. Remember, it's one of the bloody 7. So if oxygen wanted to be by itself, it'd have to be O2. So that means oxygen has to hook up somehow. So what happens is these two are going to hook up, another Tennessee couple. Congratulations. And what oxygen looks like when it does that is it's going to look like this. So you have 3 pairs of electrons. And then it has this empty space. Now I have it at 6 o'clock, but it could be at 3 o'clock, 12 o'clock, or 9 o'clock. And it is allowed to sit on a pair of electrons. So what's going to happen is that empty space is going to allow it to hook up right there. Now, it could also hook up on this one. So that means oxygen is going to go right here. Nitrogen is going to say, hey, you can form a coordinate covalent bond, and I'll provide both of my electrons for you. And then we'll have electrons like that. And that's how it would work. Electronegativity, you got to do the same thing. Nitrogen is 3. The other nitrogen will be exactly the same. When you subtract it, you get 0, which is a non-polar covalent bond. Oxygen is 3. Nitrogen is 3.5. When I subtract, I get 0.5, and this one is a polar covalent bond. That means oxygen is slightly negative, and nitrogen is slightly positive. That's the only one. Now, when you do a structural diagram, we got nitrogen. There's a triple bond between the nitrogens. And then this is a coordinate covalent bond. Once it forms, it's going to have the same strength as a regular covalent bond, a regular single covalent bond. And then this is slightly negative, and then this one is slightly positive. And that is how you do N2O. Okay? So I hope this is, you're getting this. The real test will be on your homework questions. So if you understand what you're doing, you should have no problem answering the homework questions, okay? Good luck, and have a wonderful Easter. Be safe. Bye, guys.